Assalamu alaikum. Hello, dear assistants. I'm Al-Alawi Hasna, a PhD student from the LISI Laboratory at the Qadi Iyad University, and it's a great pleasure to present to you my contribution entitled Crowdsourcing and Blockchain-Based E-Government Applications for Corruption Mapping. This work was co-authored by Professor Faziq Abdelaziz and Professor Stgal Mohammed. Starting by an introduction, I will then provide a complete description of the proposed solution, outlining the most important results and finishing with a conclusion and some perspectives. Focusing on the corruption threats, we find out that complex bureaucratic procedures requiring a lot of approbations and much time generally pave the way to this phenomenon. So fighting it requires approaches based on both appropriate principles and practices. Here comes the idea to design and implement of an integrated anti-corruption framework. But what should this solution focus on? To answer this question, we search in the literature for some existing solutions that are generally based on crowdsourcing principle. By studying these solutions, we concluded that the most of them are only awareness-raising tools like the I paid a bribe solution in India, or they are no longer active like is the case of the bribery solution in Russia, or they are not fully devoted to the corruption phenomenon as is the case of Shikaya platform in Morocco. But technically speaking, the most critical aspects is that the solutions are based on a centralized architecture. A centralized architecture is often susceptible to manipulation, to reliability risks, and to security problems. So we think that the use of a more independent technology like blockchain will be an added value. Therefore, the proposed solution is a denunciation platform based on crowdsourcing and is inspired by blockchain technology for reporting corrupt acts to make them publicly available. In this context, the following objectives have been set. We aim to ensure a full transparency and to facilitate data sharing and protection. We also aim to guarantee anonymization and by providing digital identity to each actor involved in the system. The final result will be a map or a mapping dashboard giving the public and decision makers an idea about the corruption risks in each city or each region. And finally, a rewarding mechanism or system will be implemented to motivate the crowd to participate. So the tool will be easy to use and will allow every citizen to report information on corrupt acts with a dashboard that retrieves qualitative and quantitative information on corruption. In the proposed solution, three actors are involved. There are whistleblowers that are any citizen who posts a denunciation, a government official who is responsible for handling a corrupt act from the denunciation to its conviction, and finally a miner that is a computer node responsible for validating and adding transactions. All these actors are characterized by four attributes: a pair of public and private keys, an address, and a credibility score which is updated by a smart contract. The smart contracts are also implemented to validate a transaction by a criminalization code. Once a denunciation is condemned or is considered as a corrupt act, it is then stored in a public database to disseminate all the information of the acts of corruption, the corruptors, and the corrupted people in each city or each region. All these actors are interconnected as this figure illustrates. To implement the proposed solution, we followed this multi-layered model, starting by the definition of the application architecture. For this purpose, we represent a block by a MongoDB database, where transactions represent documents. As the figure illustrates, each block represents a region with two collections. The first one stores the block meta information like the identifier, the timestamp, the nonce value, and a second collection where all the transactions are linked with their processing details or information. The second layer represents the encryption and hash methods used to ensure the system security. In this work, we use the ECDSA algorithm to ensure authenticity and confidentiality of shared transactions. These transactions are signed using public and private keys before being stored by miners. Concerning the third layer, it is about the definition of the smart contracts. In this work, we implemented two smart contracts. The first one is called objectivity analysis and contains three functions: roles distinction function, the trust management function, and an access control function. The second smart contract determines automatically whether a transaction is a potential corrupt act or not, using or according to a criminalization code. Once a transaction is validated by a smart contract, it is then processed by miners to complete the verification phase. Using a consensus protocol, all the miners come to a common agreement about the current transaction. It also helps to estimate the reward value or the reward fee. In this work, we tested the most popular blockchain consensus algorithms like proof of work, proof of stake, proof of capacity, proof of activity, etc. Finally, a transaction is then stored by the private miner and it is replicated to the whole network or the whole secondary nodes according to MongoDB replication set. Concerning the experiments, we implemented the proposed solution using Python 3.7 with two types of nodes: desktop nodes in Windows 10 environment and mobile nodes with Android 9 environments. We deployed the whole system using Flask framework, and the smart contracts were implemented using SmartPI IDE. The table here describes the distribution of the different nodes, each representing a system actor: miner, whistleblower, and governmental agent or institution. We also used some human-machine interfaces suitable for the participant registration and the denunciation forms. The results are public information gathered in a dashboard in form of mapping interfaces. The corrupt acts are structured by regions, by administrations, by services, by types of corruption, or by the victimization aspects. Technically, the performance of the system was evaluated considering the mining and the block generation operations. The tests were performed by varying the denunciation or the denunciation's throughput. The tables show respectively the delays of the denunciation validation and the generation of a block, and the comparison of different consensus algorithms' performances. We conclude that by designing and developing this system for reporting corruption acts and based on the crowdsourcing principle inspired by blockchain technology, we obtained a secure, an independent, and an autonomous platform using a rewarding system to motivate the crowd, and it is also efficient even with the smart contract execution. We concluded also that the performance weakens at a certain threshold when the system arrives at 30 claims per minute or 30 denunciations per minute, and the developed consensus algorithms are still expensive in terms of resources. We think as future work to improve these system performances by using effective platforms like Ethereum or Hyperledger Fabric. Thank you for your attention, and you can contact me for further questions or remarks or discussion for future contributions. Thank you.